Lecture 5, Part 1. Please repeat for better remembering material on the metal. And for this, multiple choice quiz. How strong is your knowledge of metal and alloys? So let's start. Which of the following metals is most likely to be used in plumbing? So, your answer, what do you think? Maybe iron or lead, titanium or copper? So, check. I think copper. So, it's right. The next question. Which word describes a metal that can be drawn into wires? So, maybe ductile? Yes. The next question. Under which conditions will iron rust the most? In contact with water and air? No. Completely coated in oil? No. In a moisture-free environment? Also no. Maybe in contact with salt water and air? Yes. Which of the following metals is the least likely to corrode? Potassium? No. Gold? Yes. Aluminium? No. Iron? Also no. Which of the following metals is extracted from its ore using electrolysis? Iron? No. Aluminium? Yes. Copper? Not. Platinum? Also not. Only aluminium is metal that extracted from its ore using electrolysis. Which of these is not an advantage of recycling metals? Maybe uses less electricity? I think not. Provides poor metals? Yes. Save mineral resources? Yes, but it's not correct answer. Reduces waste? Also yes, but also not. Which alloy is most likely to be used for dental work? What do you think? Brass? Not. Steel? Not. Solder? Not. Amalgam? Yes. Which combination of metals is used to make the alloy solder? Gold and copper? Not. Iron and zinc? Not. Lead and tin? No, yes. Mercury and silver? Not. So the correct answer, lead and tin, and this is combination of metals, is used to make the alloy solder. Which type of steel can resist extremely high temperatures and is used for spacecraft? Low carbon steel? Not. Stainless steel? Not. Titanium steel maybe? Yes. High carbon steel? Not. Which of these is shape memory alloy? Nitinol? Yes. Cupronickel? Not. Cupronickel not. Low carbon steel not. And gold also not. Only nitinol is a shape memory alloy. The next subtopic of metals, non-ferrous metals. In the previous lecture we looked at ferrous metals, also non-ferrous metals account for only 10% of all metals utilized in construction. Nevertheless, they are a very important group of materials in construction and other industries, as we shall see in this lecture. So, what is a non-ferrous metal? First, we need to clarify the difference between ferrous and non-ferrous metals. Ferrous metals are based on iron or have iron as the main constituent. However, non-ferrous alloys are not based on iron or do not have iron as the main constituent. This doesn't mean that non-ferrous metals don't contain iron several. Non-ferrous metals contain iron as an alloying element less than 10% content. Thus, it's vital to distinguish between difference between these two types of metal. The main advantage with non-ferrous metals is that generally they are relatively light in comparison to ferrous alloys, and in general they have better corrosion property. This table gives a list of various non-ferrous alloys, and in general they have better corrosion properties and mainly those used in construction. With the densities for comparison with steel. As can be seen, both aluminium and titanium are substantially lighter than iron. Iron density is 7,900 kilograms per square meter, cubic meter, and aluminium 2,700 and titanium 400 and 500. As can be seen, both aluminium and titanium lighter, and lighter than iron, and thus are extremely useful for low density, high strength application. Ultimate tensile strength of iron is up to 1000 for steels, and aluminium up to 700, and titanium up to 1200. Also, the tensile strength as a property and other properties can vary greatly for any metals, as this can be modified by treating the metal, that is heating and subsequent cooling, modifying the microstructure, etc. So in this table there is a wide range of ultimate tensile strength values for some metals. Here you can see a chemical formula of all the elements: aluminium, copper, lead, nickel, titanium, zinc, in comparison with steel, iron. So about aluminium alloys. Aluminium is one of the most abundantly available metals on Earth. Given its low density, impressive strength, and more importantly, excellent resistance to wet corrosion, aluminium is one of the most widely used and inexpensive engineering materials. In construction, aluminium alloys are used externally for window frames and structural glazing systems, roofing and cladding, flashing, rainwater goods, etc. It's used internally for ceiling, paneling, ducting, light fitting, vapor barriers as aluminium foil, architectural hardware, walkways, handrails, etc. Aluminium has the merit of being light. Density 2700 kilograms per cubic meters as compared 7,900 kilograms per cubic meters for steel, and ductile, easily rolled into sheet and thin strip and extruded into the complex section required for window frame manufacture. It resists corrosion, especially if it's anodized. However, it has only 1/3 of the stiffness of steel, and it melts at the relatively low temperature of 550-600 degrees in comparison to approximately 1500 degrees for steels. Its performance in fire is therefore not good, and so it cannot be used structurally in building. Aluminium has high electrical and thermal conductivities. As cables, it can be utilized for the transmission and distribution of electrical power. Since the late 1990s, aluminum has replaced copper conductors for these applications and is the standard material for electrical conductors. These conductors' design have consistently provided a superior combination of strength and conductivity for distribution and transmission applications. Aluminium has a distinct advantage over copper, as it's nearly 7% less dense. Due to its immense versatility, aluminium is also used in paints as a primer for use on all types of wood and aged, creosoted or bitumen-coated surfaces. It's ideal for use on fire-damaged wood after appropriate treatment. Copper and copper alloys. Copper is used extensively for a variety of applications, especially in the construction industry. Copper is used in building for plumbing, pipes and fittings, and sometimes in sheet formed for roofing. Pure copper melts at around 1080 degrees and is used in pure sheet form to cover roofs. It has a density of 8,900 kilograms per cubic meters. The weight of copper is rarely a problem. Copper is used primarily because of its excellent electrical conductivity and its high thermal conductivity, as well as its good corrosion resistance. Lead is a soft, silvery white or grayish metal. It's very malleable and ductile. Lead melts at a very low temperature of 327 degrees and is a very dense, heavy metal. Density 11,300 kilograms per cubic meters. Lead is commonly used in construction in sheet form for roofing, flashing and lead sheet cladding. Lead is dense and heavy, but it's quite corrosion resistant. It can be repeatedly bent and folded without failing, a property which is useful when forming flashing for roofing purposes. Tin is a relatively soft metal with a low melting temperature and density of 7,100 kilogram per cubic meter. In construction, zinc is used to a small extent for roofing and cladding, but its main importance in construction is as corrosion protection for steel as galvanizing. In galvanized steels, A thin coating of zinc is applied to steel items to protect them against weight corrosion. This process is cheap and it significantly extends the life of steel items in service. That is, it improves the durability of steel. This is especially economical in comparison to stainless steel, which is expensive due to the high price of chromium. More than 10% of this metal is required for stainless steel. For large-scale production, galvanizing is always preferred. Hence, nearly all structural steel beams used in construction are galvanized. Zinc is also a very important constituent in paint. Titanium is a light, strong, lustrous, corrosion resistant, including to sear, water and chlorine. Transition metal with a grayish color. Titanium can be alloyed with iron, aluminium, vanadium, molybdenum, among other elements, to produce strong, lightweight alloys for a variety of applications, especially aerospace. Titanium is recognized for its high strength to weight ratio, in addition to being light and strong with low density. It has good ductility. The relatively high melting point, about 1700 degrees, makes it useful as a refractory metal. Titanium is 70% heavier than aluminium, but more than twice as strong as the most commonly used aluminium alloy. Certain titanium alloy achieve tensile strengths of over 1380 megapascal. It's a fairly hard material, although not as hard as some grades of heat-treated steel. It's non-magnetic and a poor conductor of heat. Also, titanium is about half as light as steel, with similar strength and highly superior resistance to corrosion. It's very expensive. It would replace steel in most construction and automobile applications. Metallic bonding. A little question. Are the statements about metallic bonding true or false? Metals have a lattice structure. I think true. Yes. Metallic bonding is an attraction between metal ions. I think false. Yes. Electrons have fixed places in the sea of electrons. False. Yes. Metallic bonding allows metals to conduct electricity. I think yes. Metallic bonding allows metals to be bent. So, what do you think? I think yes. Metallic bonding lowers the melting point of metals. False? Yes. Well done. Thank you very much and have a good day. Bye.